this should be going. There we go. Turn up the mic a little bit. Okay, whenever I have to prepare a little bit, it gets a little bit wonky. Okay, let's see here. So, I don't know how to start this. For anyone that saw the previous stream or the YouTube VOD of it, this is currently going to both YouTube and Twitch. Twitch under the same name. And the other one, I just realized the category was wrong, or I remembered. Whatever. The other stream was really disorganized, and it was a total mess and a disaster. So I'm going to try and continue. I'm going to focus on Nixpkgs, but I'm going to try and go back on. Hold on, let me move this tab to a new window. There we go. So I can see both the Twitch chat and the YouTube chat at once. There we go. Oops, how do I fix this? There we go. So I'm going to assume you know a little bit about Nix and what it is. You know, otherwise, why are you watching this, I guess? You know, very few people watch this anyways. And you know a little bit about the Nix language. If you don't, sorry for the flashbang here. Then I would recommend that you look at this. You can take a look at the URL. Oops, that's not the right page, sorry. Here we go. This works, this site. I was thinking of a different one. Here we go. This is it. This is the more technical overview and such. I will mention stuff in it though, and maybe I plan to redo that video though, that stream and video, because it's a complete and total disaster. But I will be referencing this. I will be bringing stuff up. I'm going to talk about stuff, assuming, like for example, I might mention, you know, Nix shell and stuff. If you don't know what that is, like if you've never written a shell file, then don't worry about it too much. But I will be using kind of the nix-shell command. I will not be using except for the REPL, I will be avoiding the nix command for simplicity. That might make people a bit mad. I'll also be avoiding flakes a little bit because they can be useful, but they can also be a bit problematic in ways. But we shall see. In any case, though, let's see here. Why is this? There we go. So we're going to look at other resources here. This is for a technical thing, this is invaluable right here. The Nixpkgs reference manual for people looking for a really technical thing. This is going to be kind of softball. It's going to start kind of soft, but we're going to go into things that this reference manual does not. We're going to actually traverse the source code for Nixpkgs, so make sure to stick around for that. We're going to go deeper than this, I hope. It's probably not going to be too exciting, so feel free to just put this on in the background as I just go through this. I'm going to try and be organized. I have a very vague plan in my head. Probably should have written it down, but I guess now that the feed is rolling, or the video is rolling, why not just get right into it? So let's let's say that you know a bit about Nix, right? I'm assuming that you're a bit of a Nix user, or you know about it, you know a little bit, kind of getting into it, and so you've seen people use it before, so you'll know what I'm talking about when I, Nix shell, when I do something like this, like the Nix shell. I'm gonna explain that a little bit, stuff like that. But we're also going to be writing some Nix. We will not be getting into the details of writing a derivation yet, not this stream. Nixpkgs itself is just too it's just too big a topic, and I want to cover it in fair totality. Well, not totality, but to a fair degree. So that's kind of what's happening. So let's assume that we have. Let's actually start with this. What is Nixpkgs, right? You've definitely heard of it. Again, that's part of the assumptions. You've heard of it, and you've probably messed around with this before. Or if you're on NixOS, you've configured your system packages, you've configured your user packages, you've added stuff, and that usually takes the form of, you'll have with, or something like that, right? This is also super familiar if you've ever written a shell before, a shell file. By that I'm referring to like a shell.nix file. I should just say that. Anyways, but you're familiar with that, and you're familiar that we have to import, that we often have to use. With Nix shell -p, we don't have to. We just have a package here. It's a Nix package. We just p and then a list of packages, right? But if you've worked with something in a file, or something that's not kind of a shell like this, you've likely seen this before. Like as a function, arguments, my goodness, my typing today. You've likely seen something like this before, where we're using this import Nixpkgs, and I'm assuming you probably know what import is. It just lazily evaluates a Nix file. Normally you'd have a path here, but for Nixpkgs, I won't go into why you can use this angle bracket notation for Nixpkgs, but just think of it, if you're familiar with C++ header files, and you kind of know the difference between quotations for includes and the angle brackets, it's sort of like that. So that's what's kind of going on there. But why don't we just do that now? Why don't we just import Nixpkgs, right? And I think maybe first we should break down what is the syntax, right? Because if we do this, why do we have these braces on the end? If you're familiar with the the language, you can figure this out. This works as well. But you'll see that's a function, because when we import Nixpkgs, that Nixpkgs, what it actually is, the expression that gets that that comes out of it is a function. It's a lambda, and so these braces are basically evaluating it with no parameters. Use the default parameters, the default arguments, or an empty. If you're familiar with attribute set input functions, we're passing an argument to the function, and it's an empty attribute set. So we're just going to use Nixpkgs, obviously, because we can pass an empty attribute set. It has a we're going to look at that function. We're going to look at what that function looks like, the Nixpkgs function, and what can you pass in there. But for now, I think I've explained enough on that front. What those curly brackets are for, all that you always see. You're just importing with default. But obviously we want the actual packages, right? So let's do that. Let's evaluate the function, lazily evaluate it, and now we have packages here, right? What is it? What is Nixpkgs? Once it's evaluated, it's a function. But what's the return? This. What's going on here? We already have some errors and stuff. What's going on? Well, if we look at this first error, we'll see that it's kind of an artificial error here. It's a dummy package that is basically here to tell you that that you can't just go and evaluate the whole thing. You can't fully evaluate Nixpkgs in of itself. So here it says here, if you're wondering why why that fails, but we can do something like this, why we can do that, it has to do with the Nix language, right? When you're doing this, when we debug it in the REPL, we are evaluating it, but we're not evaluating the whole attribute set. Nix is very good about being lazy, and it relies on that laziness that we're not evaluating every part of the entire thing. We're just evaluating what we need, which in this case is the hello derivation, which is an attribute of packages. So if we can do that. That would be the way that we check the type of it. So we don't have to evaluate. We just get the type with built-ins.typeof. And we can see that it's an attribute set. It's just an attribute set. That's all it is. It's an attribute set that contains all the packages available in the Nix package manager. I need to warn people when that happens. Yes, it is. Yep. Hello. That drv. And why is it drv? We'll see. But these are, you go to Nix, the Nixpkgs search, and I think we all understand, these are, okay, so Nixpkgs returns an attribute set that is all of these packages, right? That's just what it is. No, not quite. It's a lot more, there's a lot more than that in here. For example, you know, often we'll see something like, I'm going to switch over, 3, 2, 1. I don't know how to set the dark theme on that website. If you've ever written a shell before, you'll know that that exists, right? You know, I'm going to do this browser in 3, 2, 1. I'm going to switch this over, 3, 2, 1. There we go. There we go. Okay. So make MK shell is in here, but that's not a package though, is it? I mean, it's a function. It's not a derivation. It's not anything. And if you search it here, what gives, right? What gives? This is because Nixpkgs contains it is both all of the packages within within the Nixpkgs package manager. You know, they're built in, but it's also the standard library for Nix. And that includes stuff like MK shell. If you've been writing derivations or you've been reading derivations, then you're probably familiar as well with you're also probably familiar with packages dot cdn, which is a derivation as well. And a derivation is just a fancy packet attribute set, right? So we can get stuff out of here. This is considered a derivation because it contains outpath. That's if it contains a dunder type or something. I can't remember exactly but I remember if it has outpath, it's considered a derivation. But it is, you can get attributes out of here, and we'll see that as well. So there's that too, and obviously that does not show up in our, more than 100,000 packages. That's not part of it too. So what's going on? You may wonder. I guess this kind of transitions into a more detailed. We're going to start looking at the source and stuff, a more detailed view of what it is and how you can come to know all of what's in Nixpkgs. So why don't we do that now? We'll hop out of the REPL and we'll go to I've cloned Nixpkgs, by the way, the GitHub repo, and this is the well, actually no, whoops, my goodness, let's look at our Nixpkgs. Okay, so it's got a default .nix, right? So this is a derivation, or not, sorry, what the heck. That's why if you just do Nixpkgs I'm thinking, like, if you just import it, this default .nix is what activates. So let's look at it here. So what are we getting? What is it returning? Well, we have first our what we can see here. We have this let, we have sort of an assertion, else we're going to, okay, so we're just kind of kicking the can down the road so far. We're going to import from packages top level / impure.nix. Okay, so let's do that. Let's look at that right now. So here we go. We have another let expression. So here we go, in. This is what we're going to return, and you can immediately see here is the function that we're evaluating. This is it. We're looking at it right now. These are our arguments that you can pass in. You can pass in local system, system, cross system, config overlays, cross overlays, and that's actually not all of them. These are the ones that you commonly see, and you use these quite a bit if you're going to use them. But there's more here. If you recognize this at args pattern, it lets you this ... at args. It lets you pass the entire attribute set of the args of the function to take as its own argument the attribute set. A couple of insertions. So we're going to remove system here, and then we're going to import. Remember, because this is PKG's top level / impure.nix. When we do this, this is going to be referring to the directory top level. So we're going to be importing top level / default.nix, and we're going to be passing it our args minus the system attribute. We're also going to add to it here, oops, excuse me, we're going to inherit these to make sure they're in the attribute set path, so that we don't pass an attribute set that has those undefined. They're guaranteed to be defined when passed to default.nix, to their defaults if necessary. So now let's go to let's go here. So this is where we start getting closer and closer into the meat of it. So here we have our more arguments. Most of these are just the top level arguments here. Excuse me. So we have a little bit of renaming here, inlets, in checked packages. So this is where things get really intimidating and really tricky. Checked is just a checker function. This is the main thing, boot stages. As we can see here, so we have boot. We actually won't really take a look at this because this is kind of complicated. This is mostly for building the standard environment, which we may come back to later. But for now, I'm just interested in, let's see all the packages that are going to be part of this. So we have the booter function. Other stages. And, boot. We're passing to the booter. We're evaluating it. Boot is evaluated the import. We're passing lib, and we're passing all packages. And this is actually where stuff is. This is going to create the standard environment, and it will ultimately, we're getting the packages out of this. It's ultimately coming out of here. But most of the packages that are not the standard environments are, basically all of them, are going to come out of here, ultimately. I'm just telling you that up front, because I want to go here first, at least. I don't plan to go here, at least for now, because I don't really care so much about how the standard library works. Where are these packages coming from? So all packages does not come from, this is confusing, from top level / all packages.nix. It's coming from import stage.nix. Well, excuse me. Top level stage.nix. And we're passing in you know, these, but let's look at stage.nix here. This is going to be a good one. So we have our stuff here. The standard environment that gets passed to it from booter.nix. Booter.nix creates the standard environment first, so it can build all these packages. So we have all of this, but the main thing here is, let's just go down here, lib.fix to fix. Fix is a function that we're not going to really look at, but let's look at here. What's going on here was to fix. We can see a series of basically these are sets of packages that are going to be in this order added to Nixpkgs. They're kind of like each stage is going to be passed to the next. For example, we start, you know, with stdinv, bootstrapping and platforms, and then that becomes the Nixpkgs, which is passed to stdinv adapters. So that's, you know, we've got both of these in standard in packages, and then we send the packages to here, and then to here, and then to here, etc., until we come to all packages and other packages. Now, all packages, this is generally where this stuff is going to be found. If you want to see where that stuff comes from, and some other stuff, I believe that make shell is in here, is in all packages, but pretty much everything that shows up that you can find here is going to be in all packages, as well as maybe other package sets. I can't remember. We can see here where these come from. They're all just args defined up here. You know, so for example, let's find here we go. Other packages. Okay, so this is other package sets. This is where all this other stuff like PKG's cross comes from, by the way. I was really confused about what is PKG's cross. This appears in PKG's, but we can basically see that we're kind of essentially just recreating the Nixpkgs for those other systems. So that's where that comes from. Packages LLVM, packages muscle. These are other attributes that basically contain the other that kind of you can see these in packages. All of these occur in packages as kind of other alternate versions, you know, alternate reality versions of packages. Let's see here. Splice. This is going to be important, especially for next stream. But let's look at all packages here, so we just see here that it's my goodness. It's coming from here, and it's a huge file. We can see here there are stuff, we can already see stuff that doesn't appear here. MK, SDN, no libs. We're importing stuff. Here's the package that is the dummy that threw the error. So let's get down here to these are our packages here, and we can see that they're all using call package here, and we're going to use that next stream. This comes from splice.nix, which we'll also look at because it's kind of interesting. That's where that comes from in case you want to see the source of that. We'll also look at the source of MK derivation next time. But these are basically pretty much your packages here. Fetchers. I forgot about these. PKGs dot fetch crate, fetch from GitLab, fetch from GitHub, etc. These are those, and you can see all the definitions. You can see where they come from. For example, and I think a good example here would be Clang here. Oh dear. Let's find it here. Here we go. So this basically lets you see, the defaults of how these are built. If you can't find it, for example, if I go to, this is a tremendous source of frustration, by the way. If you're trying to think, oh, they pull it, oh right, because it's okay. There we go. Let's look at Clang 18. I wonder if they fixed it though. No, they didn't. As you can see, it sends us to the CC wrapper, which is confusing, and where did it come from, right? We have all of this, and it's a wrapper for CC, but it's not the building of Clang. But we can find the building of Clang though. Let's see here. Where is it defined? Wait, what was that? I saw something like... Where are you? Sorry about this. This can be a little bit annoying to find though, because you can't just Here we go. My goodness, did I pass it? I certainly am silly. But we can see here these oh, okay, never mind, sorry. Here we go. This is where it's at. We get stuff like this. Oh right, I forgot to do. Here we go. LVM package set. This is kind of a pointless exercise, though, I think. Okay, yeah. There you go. A call package. I don't know why I didn't see that before. As you can see, I'm not the brightest. Um, but we're just calling. We're calling LLVM. Though, I think that's a good example of, maybe we should see. Okay, so we've seen where these are coming from. And we can see how to, see um, sometimes the arguments that are passed. Uh, so let's take a look at let's take a look at this. Um, and call package automatically provides a whole bunch of arguments to whatever gets called with, the path that gets called with. We'll see call package in a second here. We can see here this is an example of a package, how it's built. This is kind of a tricky one here. LVM might be a bad example. I was just thinking of it because I was doing research on this earlier. Why don't we look at another one that I'm more familiar with, which is Zig, because I've been trying to patch this silly derivation, this package. But we can see here that from it we're getting we're getting a lot of these attributes which are coming from call package. I don't know what this is about, the double function. It's a bit strange to me. But this is what call package does, is it looks at whatever args are in the are required and tries to pull them from packages. That's what it does. It does some other stuff too. But yes, this is the meat and bones of what a package actually looks like under the hood. So now that we're done with that pointless exercise, why don't we look back at actually look back at this. So splice, this is where call package comes from. And don't worry, we'll get to using Nixpkgs, but I want to really emphasize, because I don't think that anyone really goes through in detail how Nixpkgs works under the hood. You can find all this stuff about how to use it, especially the standard environment. You can't really find much talking about how to talking about Nixpkgs itself and how it works and such. Splice there's a reason why they call it splice, and it's and not just call package. That's what it does. So call package here is defined as new scope, but I believe, does this actually count? I think this is coming from here. I think. It could be. There you go. Uh, so we have this um, call packages with or call package with. I forgot about that they do this, but I will tell you that the idea here is to um, basically pass. Splicing the package means basically taking, um, if you have a cross system, um, like cross packages, or you've defined cross system when you called Nixpkgs, um, it will basically pass in. It will make the derivation multiple times. It will evaluate it multiple times, passing in different sets of packages based on the platform, for the platform. And this is really useful for when you're building these packages. Um, you're building these packages for another system, and you need to um, uh, like the people who are compiling, when you grab a package with nixshell-p, um, you're and like it doesn't you don't compile it yourself. It's coming pre-compiled, and that's being downloaded essentially from um, Nixpkgs, to my understanding. Um, it's downloading a pre-built derivations, pre-built packages, and those come from compilation of Nixpkgs. And obviously you don't have every single system available, so you have to cross compile, and that's why you see all those call package, call package, call package, call package for all those packages. So that you can have, you can create multiple, Nixpkgs for every, um, you can create a Nixpkgs for every system, and cross compile to those with one system without having to worry about having, basically, all the systems that are, listed here. The maximum. Um, I think there's 5 different systems that Nix supports. Theoretically, it supports a lot more, but um, these are the platforms that can use these packages. For example, if you have RISC-V, currently you'd have to patch and compile many of these. You not only have to compile these yourselves, but some of them may not work because they assume that you're on one of these, so you may have to do some patching for every derivation. The call package calls the package multiple times with different packages, different package sets, for the native system and for the target system, for the host system, the build system and the host system, and basically will see what comes out of that and splice the resulting derivations together, so that your native build inputs automatically uses the build packages, and build packages uses the host packages, because those are packages that that whatever you're building is going to use, as opposed to native, which are the packages used to actually build whatever it is, to compile it, to produce it, whatever. So like shared libraries going. You probably already know that, and I'll go over it later. But that is what call package is, and it's very useful if you're building a derivation. Uh, to be aware of that. Um, to be aware that that exists, and to be aware that other people can use it. And so that if you're making a shell that can easily cross compile, enable cross compilation, especially for testing. That's pretty important. Um, I'm trying to think what else there is to. I mean, I can keep delving deeper, but I'm not exactly sure how much that'll do. I think that I'm feeling a little bit tired here. I did not have an amazing night. Um, had a bit of an eventful night, and I did not get much sleep. But I think I've covered the basics of it and where you can go to find more. Um, how you can research this, how you can research these, these packages. Um, how you can look into how they're made and such. Things such as make shell, call package. How you can. We didn't dig into. Maybe I should dig into the standard environment and how that's built. I'll show you this, which is the I should probably kind of go over how this is structured as well. So let's so all the interesting stuff here is in oh gosh, it's going to let's just go here and let's ls. There we go. So these are, this is kind of how the top level standard environment and some other tests and some other stuff are for, this is all for, non-packages, but most of the stuff is like, and build support. This is another good one. Most of the stuff like applications, development, standard library is there, KDE, games, desktops, tools. These things are going to be your packages. They're going to be found here. That's where those are going to be stored, the derivations for them. You got to be aware that that lib is up here. std dot, or sorry, not std, nixpkgs dot lib. That comes from up here. It's its own thing, believe it or not. That is brought into packages so that you can, or whatever. I think you can also do this. I'm pretty sure you can do that. So be aware that's where that comes from. But let's look at the standard environment here. So the standard environment is booted by boot. And that's a whole process that basically goes through several phases in order to build the standard environment so that it can be built. Kind of bootstrapped. It bootstraps it and goes through several phases, essentially. And we can see here, though, that I just want to get to, where is generic. and then make derivation. This is where MK derivation comes from. I just really wanted to show this. So we can, because this is brought into, inherits MK derivation. This is a huge file. This is an issue, is that it's very difficult to follow, and I wish I could really take you through this and really take you through what's going on here, but even I haven't really sat down to really work out how this works. And even if I did, I suspect it would take me an hour to explain the basics of just what on earth is going on here. Everything. It's easy to get lost in this file. You can follow it though, and you can see some of the logic. Like, for example, in the reference manual, it will mention somewhere that if you pass a function to MK derivation, that it will represent the final, the final overrides, MK override. But this is this is where that comes from. You can see it here, that logic. But it gets a bit messy. It gets messy very fast. You can see though, everywhere that this goes, and kind of therefore all the flags that it takes, all the options it takes, you can calculate that based on this, because the documentation is not amazing. All in all, unfortunately. I think though for today, at least today, that might be all she wrote for this part. I don't think there's a whole lot more to say for now, until we get to making a derivation ourselves, which I think will be very interesting. I hope that anyone who watches this, the VOD, will kind of tell me what else I should cover in Nixpkgs, what else should I look at and explain and go through. I can do that. In any case, though, I might end the stream here, especially because I'm tired and I'm not feeling so good right now, if I'm being honest. So let's just end here.